Good afternoon, everyone. So, the last part of states of matter is liquefaction of gas. See here, liquefaction of gases. Liquefaction of gases. Liquefaction of gases means some gases can be, most of the gases in the liquid ಗೆ convert ಮಾಡೋದು. Conversion of gases into liquid. So whatever gases are there, liquefaction of gases. Gas can be converted into liquid can be converted into solids. All these states of matter are interconvertible. So solids can be converted into liquids can be converted into gas. Gas na liquids ಗೆ ಹೇಗೆ convert ಮಾಡ್ತೀರಿ? How do you convert gas into liquid? For example, solid ಅಂತಂದ್ರೆ for here, to take solid state of matter, liquid state of matter, then gas. So for example, if you take ice is in solid state, water liquid state, vapor is in gaseous state. Okay, so ice idina water agi convert ಮಾಡೋದಕ್ಕೆ what you have to do, you have to apply heat, temperature increase ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಐಸ್ ವಾಟರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಅಗೇನ್ ಆನ್ ಹೀಟಿಂಗ್, thermal stability, thermal energy. So thermal motion increase ಆಗುತ್ತೆ. So thermal energy, when you apply thermal energy, when you heat, ice is getting converted into water, which is liquid state. Water again further heating, you get converted into gaseous state. All these three states of matter are interconvertible. So vapors can be converted into liquids. Liquid can be converted into, vapor can be converted into water. Water can be converted into ice. So vapor ನಾವು ವಾಟರ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ನಾವು ಕೂಲಿಂಗ್ ಮಾಡ್ತೀವಿ. Here we apply more pressure, compress ಮಾಡಬೇಕಾಗುತ್ತೆ. ವಾಟರ್ ವೇಪರ್ಸ್ ನ ಏನು ಮಾಡ್ತೀವಿ, compress. So these are water vapors, right? Water vapor na compress ಮಾಡ್ಬೇಕು. When you compress or decrease the temperature, it will get converted into water. Water na further compress ಮಾಡಿ, again compress it, then it get converted into ice, so that is solid. So any gas, if you take any other gas also, for example, let us take carbon dioxide, CO2, ಇದು gas, it is in gaseous state, gas ಇದೆ. Okay, ಈಗ ಈ ಗ್ಯಾಸ್ ನ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅನ್ನು ನಾವು ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಮಾಡಬೇಕು. ಲಿಕ್ವಿಡ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇದನ್ನ ಸಾಲಿಡ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಮಾಡಬೇಕು. We can convert it. Okay, carbon dioxide which is in gas state can be converted into liquid carbon dioxide. Further this can be converted into solid carbon dioxide ಏನಂತೀವಿ, have you heard? Solid carbon dioxide is called as dry ice. It is called as a dry ice. 1 mark question. Competitive exams ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, solid carbon dioxide ಗೆ dry ice ಅಂತೀವಿ. This is used as a preservative, refrigerant ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So ಈಗ carbon dioxide gas can be converted into carbon dioxide liquid. This process is called as liquefaction. Okay, conversion of carbon dioxide gas into carbon dioxide liquid is called as liquefaction. In general, it is called as liquefaction of gases. So ಇದನ್ನ ಯಾಕೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ, ಒಂದು ಸ್ಟೇಟ್ ಇಂದ ಇನ್ನೊಂದು ಸ್ಟೇಟ್, ಇನ್ನೊಂದು ಸ್ಟೇಟ್ ಇಂದ ಮತ್ತೊಂದು ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇರ್ತವೆ. Here this is done by lowering pressure. Lowering pressure or high pressure, compress. We have to compress it. Means high pressure. Compress by compressing. Compress ಮಾಡಬೇಕಾಗುತ್ತೆ, compressing. So that is applying high pressure. Compress ಅಂತಂದ್ರೆ ಏನು ಹೇಳ್ರಿ? We are compressing the gas molecules. Gas molecules are compressed. When it is compressed at high pressure, pressure high ಇದ್ದಾಗ compress ಆಗುತ್ತೆ. Okay? So temperature fixed temperature ಇರಬೇಕು. So compress ಮಾಡಿದಾಗ gas can be converted into liquid. This conversion of gas into liquid is called as liquefaction. So this is an intermediate step. It is an intermediate step between gas and liquid. Gas ಮತ್ತು liquid ನಡುವೆ ಇರುವಂತ intermediate step ಇದು. So that we are going to discuss now. The last part, the last concept of states of matter. See, liquefaction of gases. Liquefaction of gases means conversion of gas into liquid. Conversion of gas into liquid. So, by taking one example, conversion of gas into liquid. This was first done by a scientist called as Andrew, taking isotherm. Isotherm plot ಮಾಡಿ ಅವರು ಅದನ್ನ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತಾರ, isotherms study ಮಾಡ್ತಾರ. So that is called as Andrew's isotherm for carbon dioxide. Particularly they are studying for carbon dioxide, CO2. Okay, so this is called as Andrew's isotherm. Andrew was the first to study, was the first person to plot a different plots, and these plots or curves are called as isotherm. What do you mean by isotherm? Isotherm ಅಂದ್ರೆ ಏನು ಹೇಳ್ರಿ? you have studied isotherm. What is isotherm? Isotherm is a curve or plot pressure versus temperature, pressure versus volume, right? Pressure versus volume, pressure versus volume, pressure versus volume at fixed temperature. Whatever curves you get, so these curves are called as isotherm at constant temperature. Temperature fixed way. This comes in which law? According to which law? Boyle's law. Boyle's law is pressure is volume is inversely proportional to pressure. Volume and pressure are inversely proportional at constant temperature. Temperature is fixed. So whatever curves you get here, such curves are called as isotherm. They are called as isotherm. Okay. See, isotherm. Let us take isotherm of see, this is an isotherm. See, carbon dioxide has been used here. Carbon dioxide is used to study the isotherms. It was done by Andrew at a different temperature, different very temperature alli avaru plots na curve ಮಾಡ್ತಾರೆ. See, y axis ಅಲ್ಲಿ pressure na ತಗೊಂತೀವಿ, x axis ಅಲ್ಲಿ volume. Y axis ಅಲ್ಲಿ pressure, x axis ಅಲ್ಲಿ volume at fixed temperature. Temperature is fixed here. Temperature na fix ಮಾಡ್ತೀವಿ, constant temperature ಇರುತ್ತೆ. So ಇದು ಏನಾಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಹೇಗೆ ಒಂದು ಗ್ಯಾಸ್, ಯಾವುದೋ ಒಂದು ಗ್ಯಾಸ್ ನಾವು ಇಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗೋದನ್ನ ನೋಡ್ತೀವಿ, ಗ್ರಾಜುಯಲಿ ಕನ್ವರ್ಷನ್ ಆಗುತ್ತೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಗ್ಯಾಸ್ ಕನ್ವರ್ಟಿಂಗ್ ಫ್ರಮ್ gas state, liquid state, then finally it is converting from gaseous state to liquid state. See, keeping temperature constant. Temperature is kept constant here. various pressures at different pressures and against volume it is plotted. That is pressure versus volume. Pressure versus volume, you get curves. Such curves are called as isotherms. Okay, temperature is constant. So Andrew got a number of typical isotherms from his experiment. It was done for whom? Carbon dioxide. Taking carbon dioxide as an example. Carbon dioxide in a study model. Okay. So this is a curve what we get. Pressure is taken on the y-axis, volume on the x-axis. Here first, if you see here, okay, see here, different temperature is taken. First 13 degrees Celsius. 13 degrees Celsius right? This volume is increasing. Pressure is low. Pressure kadme iddaga, volume jasti iddaga, you get this curve. Point AB sigutte. AB is a state where this gas exists in liquid gas state only. Then you get BC. BC at the sigata. BC here you have mixture, liquid and vapor. Then CD, where you get converted into liquid. So I'll show that first. So first you have to plot a graph, pressure versus volume. Okay. Then so you will get like this curves. So these are different temperature. For example, 13 degrees Celsius, 21 degrees Celsius. Okay, then another one, 13, 21. Again, this point is 30 degrees Celsius, 30.9, 30.98 degrees Celsius, 31.1 degrees Celsius, 48.1 degrees Celsius. ಈಗ ನೋಡಿ first type, first ಏನಾಗುತ್ತೆ, these are to show that they are in the form of gas. You main part of this part, your carbon dioxide exists in gaseous state. So this part. Okay. So what happens with increasing volume? Volume ಜಾಸ್ತಿ ಇರುತ್ತೆ, pressure ಕಡಿಮೆ ಇರುತ್ತೆ. See here, look at this point. E point ಅನ್ನು ನೋಡ್ರಿ. See, look at this point. Volume is increasing here. Volume is more here. Volume is more. Pressure is low. See, pressure is low. Volume is high. Okay. As we increase pressure, na increase ಮಾಡಿದಂಗೆಲ್ಲ. So as we increase pressure, volume decreases. Yes, as we increase pressure, volume decreases. Volume decreases. Then at certain point, when the point ಬರುತ್ತೆ ಅಲ್ಲಿ volume ಏನಾಗುತ್ತೆ, goes on decreases. Volume goes on decreases. Volume decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Pressure ಏನಿರುತ್ತೆ, constant ಆಗಿರುತ್ತೆ. Pressure constant ಇರುತ್ತೆ. Remains same. Pressure ಅಷ್ಟೇ same ಇರುತ್ತೆ. Volume decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Decreasing. Okay. And then later on volume decreases. ಮತ್ತೆ further volume decrease ಆಗುತ್ತೆ. Again volume decreases. Pressure goes on increases. Pressure increases. Okay, you will get such curve at 13 degrees Celsius. 13 degrees Celsius. ಈ ತರ ಸಿಗುತ್ತೆ. This part is called as A, B, C, D. Okay, ಇದನ್ನ A, B part, B, C part, C, D part ಅಂತ ನೇಮ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ carbon dioxide is in gaseous state. Gas to exist as gas. But here the E pointer, E area you have both liquid plus gas, mixture of both you get. ಕೆಲವೊಂದು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಲಿಕ್ವಿಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗೋದನ್ನ ಈ ಪಾರ್ಟ್ ಅಲ್ಲಿ ನೋಡ್ತೀರಿ. ಬೋತ್ equilibrium, gas and liquid are both in equilibrium. Some are in liquid, some are in gaseous state. Further, when you increase the pressure na ಮತ್ತೆ further increase ಮಾಡಿದ್ರೆ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ವಾಲ್ಯೂಮ್ goes on decreases. ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಅದು ಕಾಂಪ್ರೆಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಕಾಂಪ್ರೆಸ್, it is getting compressed. Pressure ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರುತ್ತೆ, ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇರುತ್ತೆ, means it is compressed. ಈ ಪಾರ್ಟ್ ಅಲ್ಲಿ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ ಅಂತಂದ್ರೆ you get only liquid carbon dioxide, right? Here you are getting gas. Carbon dioxide is in the form of gas. 13 degrees Celsius temperature we are talking about. Temperature is fixed here. Temperature is 13 degrees Celsius. 13 degree temperature na fix ಮಾಡಿದಾಗ 13 degrees Celsius fix ಮಾಡಿದಾಗ ವಾಲ್ಯೂಮ್ ನ ಕಡಿಮೆ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀವಿ. ವಾಲ್ಯೂಮ್ ನ ಕಡಿಮೆ ಮಾಡ್ತೀವಿ. AB part, AB you get where carbon dioxide exists in gaseous state. Further ವಾಲ್ಯೂಮ್ ನ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ, ಫರ್ದರ್ ವಾಲ್ಯೂಮ್ ನ ಮತ್ತೆ ಕಡಿಮೆ ಮಾಡ್ತೀವಿ. ಫರ್ದರ್ ವಾಲ್ಯೂಮ್ ನ ಕಡಿಮೆ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಪ್ರೆಷರ್ ಏನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಈ ಪಾರ್ಟ್ ಅಲ್ಲಿ, ಪಾರ್ಟ್ BC ಅಲ್ಲಿ you get equilibrium. You have both acid, I mean gas as well as liquid. Gas, liquid ಎರಡು, liquid carbon dioxide, gas carbon dioxide both are there. Further ವಾಲ್ಯೂಮ್ ನ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಕಾಂಪ್ರೆಸಿಂಗ್, we are compressing. ಪ್ರೆಷರ್ ಏನಾಗುತ್ತೆ, ಸ್ಟಿಲ್ in pressure high ಆಗುತ್ತೆ. ಈ ಪಾರ್ಟ್, in this part you get only liquid carbon dioxide. So gas ಇದ್ದಿದ್ದು ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಲಿಕ್ವಿಡ್ ಗೆ. Gas carbon dioxide getting converted to liquid. Okay, this is at 13 degrees Celsius. So what happens at 21 degrees Celsius? 21 degrees Celsius ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನೋಡಿ, again same thing, you get carbon dioxide, gas. ಈ part ಅಲ್ಲಿ here again carbon dioxide exists in liquid as well as gas, ಎರಡು ಇರುತ್ತೆ in this part. But if you see compared to ಇದನ್ನ ಮತ್ತೆ ಇದನ್ನ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಏನಿದೆ, this point is decreasing, right? ಈ ಪಾಯಿಂಟ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. See here, part BC is decreasing, part BC is decreasing, short ಆಗುತ್ತೆ. Then later again you get liquid carbon dioxide. Okay, ಮತ್ತೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ ಗೆ ಮಾಡಿದ್ರು ಇದೇ ಸಿಗುತ್ತೆ, ಇದೇ ತರ ಸಿಗುತ್ತೆ. up to where, up to 30 degrees Celsius, 30.98 degrees Celsius ಅಲ್ಲೂ ಇದೇ ಆಗುತ್ತೆ. ಬಟ್ 30.98 degrees Celsius ಆ ಟೆಂಪರೇಚರ್ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ you can see all it exists as gas only. So ಈ ತರ ಕರ್ವ್ ಸಿಗುತ್ತೆ at 31 degrees Celsius, 30.98, 31 degrees Celsius, 48.91 degrees Celsius. In together you get a curve like this. You get a curve like this. This means it exists in gaseous form only. Carbon dioxide exists as gaseous form only. There is no liquid carbon dioxide. Means at this temperature 30 degrees Celsius, 30.98 degrees Celsius ಗೆ ಗ್ಯಾಸ್ ಆಗಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ, ಕನ್ವರ್ಟ್ ಆಗಲ್ಲ. 31 degrees Celsius ಗ್ಯಾಸ್ ಆಗಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಇವನ್ ಇಫ್ ಯು ಅಪ್ಲೈ ಮೋರ್ ಅಂಡ್ ಮೋರ್ ಪ್ರೆಷರ್, ಎಷ್ಟೇ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ರಿ, ಎಷ್ಟೇ ವಾಲ್ಯೂಮ್ ಅನ್ನ ಕಡಿಮೆ ಮಾಡಿದ್ರು ಗ್ಯಾಸ್ ಆಗೇ ಇರುತ್ತೆ. 48 degrees Celsius ನೋಡ್ರಿ, ಇವನ್ ಯು ಅಪ್ಲೈ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಲ್ಯೂಮ್ ಅನ್ನ ಕಡಿಮೆ ಮಾಡ್ರಿ, ಪ್ರೆಷರ್ ನ ಜಾಸ್ತಿ ಮಾಡ್ರಿ, gas exists as gas only. Means below this temperature You can see gas is converting into liquid. But above this temperature, how much ever pressure you apply, ಎಷ್ಟರ ಪ್ರೆಷರ್ ಹಾಕ್ರಿ, ಎಷ್ಟರ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಮಾಡ್ರಿ, ಎಷ್ಟರ ಹೈ ಪ್ರೆಷರ್ ಹಾಕ್ರಿ, ಏನಾರು ಮಾಡ್ರಿ, ಅದು ಗ್ಯಾಸ್ ಆಗೇ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಟೆಂಪರೇಚರ್, ಈ ಟೆಂಪರೇಚರ್ ಏನಂತೀವಿ, ಕ್ರಿಟಿಕಲ್ ಟೆಂಪರೇಚರ್. ರೈಟ್, ದಿಸ್ ಟೆಂಪರೇಚರ್ is called as critical temperature. Okay, and the volume, our temperature alli our volume ige enantivi critical volume, critical pressure. So same thing is here. See, isotherm, let us read out this once again. Whatever I have explained, same thing is here. Isotherms at temperature much above critical temperature 31. These are very much like ideal gas isotherm. Andre ivaru yadra ಬಗ್ಗೆ ಹೇಳಾಕತ್ತಾರೆ, ಇದು ಫಸ್ಟ್ ಒನ್, ಇದನ್ನ ಹೇಳ್ತಾರೆ, ಫಸ್ಟ್ ಕರ್ವ್. ಸಿ isotherm 1 ಅಂತ ಹೇಳಾಕತ್ತಾರೆ. ಸಿ isotherms at temperature above critical temperature. Critical temperature is to 31.1 critical temperature. ಆ ಟೆಂಪರೇಚರ್ ಅಬೌವ್, ಆ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ನಾವು ಎಷ್ಟರ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಮಾಡಿ, ಎಷ್ಟರ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಮಾಡ್ರಿ, ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಮಾಡ್ರಿ, ಏನಾರ ಮಾಡ್ರಿ, ದ ಗ್ಯಾಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಸ್ ಗ್ಯಾಸ್ ಓನ್ಲಿ. ಸೊ ಅಟ್ ದಟ್ ಟೈಮ್ ಇಟ್ ವಿಲ್ ಬಿಹೇವ್ ಆಸ್ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ. ಯಾವಾಗ 31 ಡಿಗ್ರಿ ಟೆಂಪರೇಚರ್ ಮೇಲೆ, above that. So ಇದು ಫಸ್ಟ್ isotherm. Okay, then next one, isotherms at temperature just above critical temperature, have a point of inflection which is not found in ideal gas isotherm. Avaru yav ಬಗ್ಗೆ ಹೇಳಾಕತ್ತಾರೆ ಅಂತಂದ್ರೆ they are telling about isotherm second ಬಗ್ಗೆ ಹೇಳಾಕತ್ತಾರೆ. See here, that means this one ಯಾವುದು, ಇದು this part, ಇದನ್ನ ಹೇಳ್ತಾರೆ, ಇದು ಫಸ್ಟ್ ಒನ್. ಇಲ್ಲಿ ಏನಾಯ್ತು ನೋಡಿ, one small deviation ಆಗುತ್ತೆ. You can see this point, ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಕಾಣಿಸುತ್ತೆ, ಜಸ್ಟ್ ಅದು ಪಾಸ್ ಆಗಿ ಹೋಗುತ್ತೆ, ಬೇಗ ಪಾಸ್, ಆ ಪಾಯಿಂಟ್ ಪಾಸ್ ಆಗಿ ಹೋಗುತ್ತೆ. You can see a kind of curve like this. Above 31 you can see like this curve, but at this point 31 point ಯಾವ ತರ ಸಿಗುತ್ತೆ, ಈ ತರ ಸಿಗುತ್ತೆ. This is called as inflection ಅಂದ್ರೆ just ups and downs. You can see a point here. ಯಾವ point, f point. Okay, so then third type of isotherm at temperature just above critical temperature show a horizontal part. See here, ಈಗ ಇವೆರಡು ನೋಡ್ರಿ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಇಲ್ಲಿ horizontal line ಸಿಗುತ್ತೆ. You can see here horizontal line, two lines you can see, straight path, horizontal path. So these are third and fourth isotherm. ಇದು ಮತ್ತಿದು third and fourth isotherm. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ actually ಅಂತಂದ್ರೆ, in this case there is a discontinuous of liquefaction ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಗ್ಯಾಸ್ ಮತ್ತೆ ಲಿಕ್ವಿಡ್ ಎರಡೂ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. You can see liquid plus vapor, both are there. Liquid plus both are there in this horizontal path. ಈ path ಅಲ್ಲಿ, in this part you can see both liquid and vapor form. Okay, and the temperature at which, particular temperature above which a gas cannot be converted into liquid, that temperature is called as critical temperature. See, the temperature at which gas cannot be converted into liquid is called as critical temperature. So this is to show how gases are gradually converted into liquid. Gases ಹೇಗೆ ಗ್ಯಾಸ್ ಸ್ಟೇಟ್ ಇಂದ ಸ್ಲೋಲಿ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ, ಹೇಗೆ ಕನ್ವರ್ಷನ್ ಆಗುತ್ತೆ ಅದನ್ನ ತೋರಿಸೋದಕ್ಕೆ ಇದು ಐಸೋಥರ್ಮ್. ಬಟ್ ಒಂದು ಪಾಯಿಂಟ್ ಅಂತ ಇರುತ್ತೆ, ಒಂದು ಟೆಂಪರೇಚರ್ ಅಂತ ಇರುತ್ತೆ. ಆ ಟೆಂಪರೇಚರ್ ದಾಟದ ಮೇಲೆ ನೀವು ಎಷ್ಟೇ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಅದು ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಯಾವ ಟೆಂಪರೇಚರ್ ಅದು 31 degrees Celsius. ಈ ಟೆಂಪರೇಚರ್ above what happens? It will behave ideal ಆಗಿ behave ಮಾಡುತ್ತೆ. ಈ ಟೆಂಪರೇಚರ್ below this temperature what happens? It exists as gas plus liquid. Okay, see here Andrews plotted isotherms of carbon dioxide by taking different temperature, very temperature ತಗೊಂಡು isotherm ನ plot ಮಾಡ್ತಾರೆ. He noticed that at higher temperature ಜಾಸ್ತಿ ಇದ್ದಾಗ 40 degree Celsius 50 degree Celsius ಇದ್ದಾಗ gases behave ideally. Temperature ಜಾಸ್ತಿ ಇದ್ದಾಗ gases behave ideally. Above 31 they behave ideally. Maximum temperature at which gas can be liquefied. See here. The maximum temperature at which gas can be liquefied is called as critical temperature. The temperature is called as critical temperature. It is given as Tc. In case of carbon dioxide, it is 31.1 degrees Celsius. Below the temperature. This one. This temperature 31. E point. E temperature ಏನಾಗುತ್ತೆ ಅದು point reach ಆಗುತ್ತೆ. 31 degrees Celsius is called as critical temperature. E temperature above ಏನಾಗುತ್ತೆ? How much ever you pressure apply, it will be ideal only. Gas ಆಗೇ ಇರುತ್ತೆ. Below this temperature, you have both gas plus liquid. Okay. See, this temperature is called as critical temperature. At this temperature, ಈ temperature ಅಲ್ಲಿ 1 mole of gas ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಅನ್ನು ಆಕ್ಯುಪೈ ಮಾಡುತ್ತೆ ಆ ವಾಲ್ಯೂಮ್ ಗೆ ಏನಂತೀವಿ? critical volume. It is called as Vc. Okay, ಈ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ರೆಸ್ಪೆಕ್ಟಿವ್ ವಾಲ್ಯೂಮ್ ಏನಿರುತ್ತಲ್ಲ ಆ ವಾಲ್ಯೂಮ್ ಗೆ ಕ್ರಿಟಿಕಲ್ ವಾಲ್ಯೂಮ್ ಅಂತೀವಿ Vc. ಈ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಯಾವ ಪ್ರೆಷರ್ ಇರುತ್ತಲ್ಲ, so what pressure is there, that is called as critical pressure. Pc. Okay, critical temperature, critical volume, critical pressure. So see here like this. E point, at this point, this is critical temperature. E point exact at this point, ಏನು volume ಇರುತ್ತೆ? What is the volume here? This volume is called as Vc. That is critical volume. E point ಅಲ್ಲಿ pressure ಏನಿರುತ್ತಲ್ಲ, that is called as critical pressure. ಏನು pressure ಇಲ್ಲಿ ಯಾವ pressure ಇರುತ್ತೆ ಅದು critical pressure. ಇಲ್ಲಿ ಯಾವ volume ಇರುತ್ತೆ ಅದು critical volume. Temperature ಏನು? 31 degree Celsius. 31 degree Celsius critical temperature. ಯಾಕೆ 31 degree Celsius critical temperature? 31 degree Celsius ಮೇಲೆ ಏನಾಗುತ್ತೆ? ಮೇಲೆ above this temperature ಏನಾಗುತ್ತೆ? gases ಎಷ್ಟೇ ನೀವು ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿ, ಎಷ್ಟೇ ವಾಲ್ಯೂಮ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಅದು ಗ್ಯಾಸ್ ಆಗೇ ಇರುತ್ತೆ. ಅದು ಐಡಿಯಲ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ. ಅವಾಗ ಅದು ಏನು ಮಾಡುತ್ತೆ? ಐಡಿಯಲ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ. ಈ ಟೆಂಪರೇಚರ್ ಕೆಳಗೆ ಏನಾಗುತ್ತೆ? ಬಿಲೋ ದಿಸ್ ಟೆಂಪರೇಚರ್ ಏನಾಗುತ್ತೆ? ಯು ಹ್ಯಾವ್ ಗ್ಯಾಸ್, ಯು ಹ್ಯಾವ್ ಲೈಕ್ ದಿಸ್ ಕರ್ವ್ಸ್ A, B, C, D. ಈ ತರ ಪಾರ್ಟ್ ಸಿಗುತ್ತೆ. ಇಲ್ಲಿ gas, ಇಲ್ಲಿ gas plus liquid, ಇಲ್ಲಿ liquid. The temperature below. Above this temperature you get like these curves. These curves are called as isotherms. Ideal gas curves. Okay? Followed? So this shows that conversion of gases into liquid. Discontinuous. It is discontinuous below critical temperature. Okay, so what is critical constant? Critical constants. Andre no, what are critical constants? You have three critical constants. 1, 2, 3. Critical temperature, critical volume, and critical pressure. Critical temperature, critical pressure, critical volume. Critical temperature is given as Tc, Vc and Pc. Critical temperature antu niಮಗೆ ಗೊತ್ತು ಎಷ್ಟದು critical temperature for carbon dioxide. I am talking about for carbon dioxide 31.1 degrees Celsius. ಎಷ್ಟಿರುತ್ತೆ critical temperature for carbon dioxide is 31 ಅದು 31.1 degrees, that is sorry 30.98 degrees Celsius is a critical temperature. And at this point, E point ali temperature ali, what is the volume occupied? How much ml occupied? What is the volume here for 1 mole of gas? 1 mole of gas ge ಎಷ್ಟು volume occupy ಮಾಡುತ್ತಲ್ಲ, so that is called as critical volume. At this point ಏನು pressure ಇರುತ್ತೆ, ಏನು mmHg ಇರುತ್ತೆ ಅಥವಾ ಏನು bar pressure ಇರುತ್ತೆ, so that pressure is called as critical pressure. So in detail you are going to study in higher classes about all this. Okay, this in here you have to discuss only about conversion of gas into liquid. ಇದರ ಬಗ್ಗೆ ಡೀಟೇಲ್ ಆಗಿ ನೀವು higher classes ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀರಿ. Values ಬಗ್ಗೆ ನೀವು in detail ಆಗಿ you are going to study in higher classes. Okay, you have to remember only a important point here. ಏನು important point ಅಂತಂದ್ರೆ temperature ಕಡಿಮೆ ಇದ್ದಾಗ 13 degrees Celsius, 21 degrees Celsius, you have 3 parts like this. Part AB, BC, CD. This is a part where it exists in gaseous state. Gaseous state. This shows it is in gaseous state. Okay. This point shows gas plus liquid. Both are in equilibrium. The next part, this part shows liquid carbon dioxide. Here gas, carbon dioxide, liquid carbon dioxide, and here both liquid plus gas carbon dioxide. Okay, here also same thing happens. Idenidu gas carbon dioxide, and here you have mixture, and here you have both 3 parts. Following ಎಲ್ಲಿವರೆಗೆ ಈ ತರ ಇರುತ್ತೆ at a point critical temperature ಬರುವವರೆಗೂ ಇದೇ ತರ ಇರುತ್ತೆ. ಓಕೆ, critical temperature point ಬಂದಾಗ critical temperature point ಯಾವುದು? Critical temperature point ಇದು ಈ ಪಾಯಿಂಟ್, that is 30.98 30.98 degrees Celsius. 30.98 degrees Celsius. And you want the curve concept. You get a curve like this. You get a curve like this. Okay. Infection a point. This point is called as F point. F point. Here you can see there is a change of, there is no conversion of a gas into liquid. It's very faster here. After this point, the point ಆದ್ಮೇಲೆ 31 degrees Celsius, ಅದಾದ್ಮೇಲೆ 40 degrees Celsius, ಅದಾದ್ಮೇಲೆ 50 degrees Celsius. Here you can see all this, you can see it is in gaseous state. It is in gas, carbon dioxide, gas, carbon dioxide, gas, carbon dioxide. Means it is ideally behaving ideally. Ideally behave ಮಾಡುತ್ತೆ. So these are called as entry-use isotherm. Okay, this point, this point where you can see conversion of gas into liquid, after that you don't see any conversion, this is called as critical point. Inflections, inflections, so this is called as critical point. This point above this temperature 30.98 degrees Celsius or 31 degrees Celsius, you see only gas. You see only gas, no liquid carbon dioxide. So this temperature is called as critical temperature. This temperature below liquid carbon dioxide exists. This temperature above liquid carbon dioxide does not exist. Okay. So details about this you are going to study in next class, that is in higher classes. Okay. So this part is for gas, this part is have mixture, gas and liquid, and this is only liquid carbon dioxide. Okay. So this point is called as critical point, and above this you have a temperature called as critical temperature. And at that point, whatever pressure, volume you have called as critical volume and critical pressure. So this is called as entry-use isotherm for carbon dioxide. So you can convert any gas into liquid. ಯಾವುದೇ gas ಅನ್ನು liquid ಆಗಿ convert ಮಾಡಬಹುದು at a particular temperature. ಒಂದು temperature ವರೆಗೆ ಮಾತ್ರ. After that, you cannot convert gas into liquid. ಅದು carbon dioxide ಗೆ ಯಾವುದು temperature is 31 degrees Celsius. Nitrogen ಗೆ ಬೇರೆ ಇರುತ್ತೆ, oxygen ಗೆ ಬೇರೆ ಇರುತ್ತೆ, ಬೇರೆ ಬೇರೆ gases ಗೆ ಬೇರೆ ಬೇರೆ critical temperature ಇರುತ್ತೆ. Okay, so this is for carbon dioxide. So with this we have completed states of matter. Problems, numerical problems on states of matter will be discussing in next class, or will be discussing when we are discussing CET. CET discuss ಮಾಡುವಾಗ there only will discuss numerical problems on states of matter. Okay, so with this states of matter chapter is completed. Tomorrow we'll be taking next chapter, or we'll solve some problems on this. So hope it is clear. In the next class we'll continue numerical problems on states of matter.